It's good to have you this morning. Yeah, in our last contact, we began solving this question and we were able to provide justice to it even to the end. That's where we are going to start this morning. And the question is on titration, that is the reaction between acid and base, that's neutralization reaction. So that is basically what we have here on the board. All right, we are not going to be having the practical setup here, but let's assume you have carried out the practice, yes, the titration in your laboratory. You are going to have this. How do you proceed from this juncture? That is where we are. All right, I remember that in our last contact, I made you know that whenever you are choosing, you want to calculate the average volume of acid used, you must be very careful in the sense that the values, or let me say the titer value in each of your titration, you have your rough titration here, you have your first titration, you have your second titration, you can have your third titration depending on the time you have. So if you are going to choose whether this value or this value, depend on a factor. And I told you that day that the difference between the value you are choosing must not be more than 0.20 mole, ml rather, 0.20 ml or 0.20 centimeter cube. So now when you now look at this, the first titration, you have the volume to be 25.00 centimeter cube or ml. In this case you have it to be 24.50, and in this case you have it to be 24.70. Now when you look at each of these um acid used in each of these titration, you realize that when you consider the difference between this and this, the difference is 0.50, and automatically it means you cannot choose this and this. Now let's look at this and this, that is the rough titration and the second titration. When you look at the rough titration, the volume of acid used there is 25.00. Now look at the second titration, the volume of the acid used there is 24.70. When you find the difference is 0.30 ml. So you cannot use the rough titration and the second titration. Now let's look at the first titration and the second titration. You realize that the difference between them is just 0.20. Simple as that. You can go ahead and use the two of them, that is the first titration and the second titration. All right, it will do you good to know that if your rough titration is not different from first titration by more than 0.20, of course you can choose your rough titration and involve it in the process of your calculating the average volume of acid used. But in this case, because it's the difference of this from this is more than 0.20, and from the second titration we are going to leave it out in the process of calculating the average volume of acid used. All right, of course you know there are some factors that must be stated. The volume of the pipette you use. Now the volume of the pipette we used in this case, let's say, is 25 centimeter cube. Of course you have to state your indicator as well. Your indicator is methyl orange. In this case, indicator is methyl orange. And don't forget, from where we are, what we have been discussing, the reaction is between A and B. And what is our A? Our A is our H2Y is an acid, while our B is sodium hydroxide. Now, some information were provided for us concerning this A and B. Now, what you know about A is that A is a solution containing 6.22 gram of an acid H2Y per dm cube. It means you have been given the mass concentration of this, and the mass concentration is 6.22 gram per dm cube. While B is a solution of 5.6 gram per dm cube of sodium hydroxide. It means the mass concentration of solution B, which is sodium hydroxide, is 5.6 gram per dm cube. All right, so, and I've stated that the volume of the pipette we are using is 25 centimeter cube. Now let's continue. Now let us assume you have tabulated our reading. Now the very first thing you have to do is calculate the average volume of acid used, and that's where we are starting from. So the first thing is, I told you you use this and this, so it's going to be first titer value plus second titer value. Now, how many value did you take? You took just two values, this and this, so it's going to be divided by 2. And what's your first titration? The first titer value is 24.50 ml, plus 24.70 ml, all divided by 2. Now let's punch that and see what we are going to have. 24.50 plus 24.70 divided by 2. We have the average volume of acid used, or average volume of A used, is 24.60 ml or centimeter cube, whatever you call it. They are both the same. Now we have been able to arrive at this. Now let's go to look at the second question. Now the equation of the reaction between A and B was provided for us, and this is the equation. Please look at it. We have our H2Y aqueous plus 2NaOH. This is our solution of B. Now giving us, this is also aqueous, giving us Na2Y. All of this will be provided for you in your question, so you don't have to panic. Plus 2H2O liquid. Is this balanced? Let's check. We have two hydrogen, 4. This equation is balanced. Now the very first question is, and you know the molar mass of each of these. All right. So from your result and information provided, calculate the concentration of B in mole per dm cube. Very simple. Now we know that this is the average volume of acid used. Now calculate the concentration of B in mole per dm cube. Now we don't have anything to do with this table anymore, since what we needed there has been derived. So we can clean this and let's see. You can use this part of the board to get answers that you are required to provide. All right. Calculate the concentration of B in mole per dm cube. All right. Concentration in mole per dm cube is going to be concentration